second uh, special right triangle is what's called a 30, 60, 90 right triangle. And so this is another one that shows up very frequently. In fact, it's actually, if you take a look at your picture, this is kind of half of an equilateral triangle. If I were to draw another one, I'd end up with 60, 60, 60, right? And you'd end up with an equilateral triangle. So this is useful in finding things in equilateral triangles as well. So we're going to just apply this rule again. So in a 30, 60, 90 triangle, there are two relationships instead of one. So here's the way this one works. We're going to call across from the 30-degree angle, okay, the short leg. And we know this is the short leg because across from the smallest angle in any triangle is the smallest side, right? Across from the 60-degree angle, we'd say is the longer of the two legs because that's bigger than 30. And then again, the across from the 90-degree angle, we have a special name for that. We call that the hypotenuse, right? And so we're going to set up two rules. We're going to say if you multiply the short leg by 2, you will get the hypotenuse. If you multiply the short leg by the square root of 3, you will get the longer leg. So there's two different relationships here, and both of them are related to the shorter leg, which is across from the 30-degree angle. Okay, so let's come down and take a look at an example of how we could apply this. So in this example, okay, we're looking at and we're saying, okay, across from the 30 degrees, this is what I would call, okay, let me get a different color. This is what I would call the short leg. Okay, across from the 60, this is called the long leg. Okay, and again, across from the hypotenuse, we know is called, across from the 90 is called the hypotenuse. So if I'm looking at this problem, it looks like I would like to know about the short leg, and they told me about the hypotenuse. So I'm going to, again, write down the rule, which says hypotenuse equals 2 times the short leg, and I'm going to plug in what I know, and that's that the hypotenuse is equal to 6. So 6 is equal to 2, they call the short leg x. So it looks like in this case, x has to be equal to 3, right? So we found it. X is 3. We could also find the long leg in this case. If we want to know the long leg, if the short leg is 3, it looks like the long leg would be 3 square root of 3, right? So there's kind of another expansion on that same rule. So this one's the trickier of the two problems, right? So in this case, they're saying, all right, we know that this is 12, this is 60, which means this little space up here is 30. Right, so again, let me label the three sides just until we get used to just looking at them and knowing. 12, if I focus just on this little right triangle, 12 is the hypotenuse of that. Right, across from the 30 is what I'd call the short leg. Okay, and across from the 60, this x that they'd like to know about, this is the long leg. Okay, and so I'm going to start with what I know. This is 12. Okay, so my rule up here says if you know about the hypotenuse, you can find the short leg. So let's just write that down. Right, it's going to be the same rule that says hypotenuse equals 2 times the short leg. Okay, and so I know the hypotenuse is 12, and that equals 2 times the short leg. Okay, and so it looks like the short leg, if I divide both sides by 2, the short leg is going to be 6. Right, so I'm going to go up here and fill that in, that the short leg here is 6. And the reason that I did that is because the long leg is related to the short leg. So I need to know what that is before I can use this rule to figure out what the long leg is. So I'm going to come back here now and I'm going to say, now that I know that the short leg is 6, let me write down that rule that said that the long leg is equal to the short leg times the square root of 3. And so now that I know that the short leg is 6, I use the hypotenuse short leg rule to find the short leg. Now I can plug in this as 6 square root of 3, and that is what equals the long leg, which is what they called x. So I know that this is 6 square root of 3. So there might be times where you have to use the short leg hypotenuse rule, even though you really want to know about the long leg. You have to actually use the one rule to find the short leg, and then use the short leg to find the long leg, because they're both related to the short leg in our problem. Okay, so again, there might be some more complex examples where you might have to rationalize the denominator or work your way backwards through problems, but these are the basic concepts that we're going to see in our problems.